Hello everyone, how are you all doing? Hope all of you are safe, healthy and taking care of yourself as well as your family members. So students, welcome into the new subject in the new arena of programming, that is object-oriented programming. Before we will see the contents of the subject, I just wanted to give an idea that how these online sessions will be conducted. So you will be having a 20 minutes of recorded session on the YouTube. The link will be shared with you just 5 to 10 minutes before of the session. You have to watch that session of 20 minutes. Once that session will be finished, later on we will have a 20 minutes of live session on the Google Meet. In that, we will again discuss the topics that we have discussed in the recorded session. If you have any queries in this recorded session, you can point it out and we will try to solve them in the online session. So I will recommend you have a notebook with you, have a pen ready with you so that whenever you will have any query, you can just enlist in your notebook and in the online session, you can sort them out. Once this online session will be finished, so in the first 20 minutes, we will have a recorded session. Another 20 minutes, we will have a live session. And once that will be finished, then you will have a Google form in which you have to give an MCQ assignment. So you have to finish up that assignment on that day itself. So if your session will be over by, let's say, 1 o'clock in the afternoon, by 7 o'clock on that day itself, you have to finish that MCQ assignment, okay, which will be available on the Google form. Also, for the descriptive type of questions, I will give you a PDF wherein I will give you some 5 to 10 questions whose assignments you have to solve in the notebook, that is in assignment book, and that you have to furnish whenever you will come physically into the college. So hope structure is clear to everyone and you will enjoy all these sessions. So let's begin and we will see what contents we have to see in the object-oriented programming. Now here is a copy of your syllabus. So the rationale behind learning this subject is to understand the new paradigm of programming. We will see in detail that why this new paradigm is supposed to be learned. Because in earlier paradigm, we learnt procedure-oriented programming or functional programming, that was C. Now why it is really needed to learn something new, to learn the new paradigm of programming, that is object-oriented programming, that we have to see in this particular subject. So object-oriented programming is a paradigm. Is a paradigm in the sense it's an entirely new structure of doing the programming. And in the object-oriented programming umbrella, you have other languages like C++, Java. These languages comes under the object-oriented programming arena. So we have to understand object-oriented programming using C++ language. So we will start looking at the C++ later on, but before that we will actually see what object-oriented programming is, what is new in the object-oriented programming and why it was really needed to find out something new when earlier C language was available with the powerful objectives. So that is the rationale behind learning this subject. After learning this subject, you will be competent to develop applications using object-oriented programming concepts in C++. Then here are some of the course outcomes. So you have to develop C++ programs to solve problems which you solved using procedure-oriented approach earlier. Then you have to develop C++ programs using classes and objects. So far we don't know what classes and objects are, so that we will see in the later on phases. Then we have to implement inheritance in C++ program. This is a beautiful feature of the object-oriented programming, that is inheritance, that we will see. This is very interesting. Then we have another feature, that is a polymorphism in the C++ program. That also we will see in this course. And then we have to develop C++ programs to perform file operations. So that means you have to save your contents on the hard disk. Here is the teaching and examination scheme. So in the end semester exam, you will have a 70 marks of paper, which will be a written paper that you have to give in 3 hours. Minimum score that you will want is a 28. Then under the theory head, you will have a progressive assessment that will be done out of the 30 mark. That assessment will be done out of 30 marks, and this is how total 100 will be calculated. Under the practical head, you will have end semester exam out of 25 marks. In that, you have to score minimum 10 marks for the clearing this subject. Also, you will have a progressive assessment under the practical. So that will be done out of 25 marks. So this is how 50 marks will be calculated. In order to achieve practical expertise in this subject, you have some practical assignments. So for the practical outcomes, you have some assignments given over here. These are 19 assignments. So probably you will get a manual for it. And once you will have the manual, all these 19 assignments will be there in that. You have to solve them in order to achieve these practical outcomes. Here are some performance indicators based upon which your practical assignments will be evaluated. So 40% weightage will be given for the correctness of algorithm. Now, while solving a problem, we have to design an algorithm. So how much correct your algorithm is, how much efficient your algorithm is, based upon that, this evaluation will be done. Then 20% weightage will be given for the debugging ability. Now this is an ability to sort out programmatical errors. So if you will have any errors in the program, syntactical errors or many times logical errors, then how efficiently you can solve them. That we have to monitor, and accordingly this 20% will be given. Then 10% are reserved for the quality of input and output that you are displaying on the screen. Now right from the beginning I told you that in the program, as a end customer, what you're going to see is the input and output. So how efficiently and how properly you are taking input from the user and how you are articulating your output, that is very important. Okay, so you have to use correct messages, you have to use correct parameters while displaying an output. So for that, the 10% weightage is reserved. And then there are some sample questions for that 20%, and how you are submitting your report. Okay, for that 10% marks are reserved. So hope the percentage is clear to you. How we are going to evaluate your performance, that is also clear to you. So we will keep on following these parameters, and based upon that only evaluation will be done. Here are some equipments that we will need in order to perform practicals. So of course we will need a computer system. Along with that we will need C++ compiler. So you may use Turbo C++ compiler, which I will recommend you to use if you have. Otherwise we will start with Eclipse directly. Okay, because Eclipse is the best option to start off with the C++ programming. So maybe we will start with the C++, but I will strongly recommend you, if you have a Turbo C++ compiler, then just begin with that. That is good option to start with. Then in Unit 1, you have to learn principles of object-oriented programming. So here we have to actually understand why object-oriented programming is important to learn, what is the specialty of object-oriented programming, and the need of object-oriented programming. So straight away we will get started with the syllabus with the unit number 1. Before we will move ahead, we will go a little bit back and we will see the history of programming languages. So initially we had machine level language or a binary language to interact with the hardware. As we wanted to interact with hardware, we wanted to give some instructions to hardware, we needed some physical signals to send our data to our hardware. And for that we used some physical entities, like if we are passing the current, we said that is 1, and when we are not passing any current, to that we said 0. So that was the initial language, or that was a hardware level language to interact with the hardware, 0 and 1. So we started having an interaction with the hardware using binary level language, that is 1 and 0. Initially that was alright to interact with the machine using binary language. because we had very small code that we can directly give instructions using some zeros and ones. But later on, it was getting difficult to interact with the machine using binary language. The reason was very obvious that 0 and 1s, it was really very difficult for a human being to understand it. It was all okay for the machine to understand the instructions in the form of zeros and ones because it was its own language. But for a human being, if I will give some instructions only in the form of zeros and ones, it will be difficult to work with that language. The program will become larger. Also, it will become incomprehensible. So after one limit, you cannot interpret whatever the code you have written. So that was the major challenge. And that challenge was sorted out using assembly language. So what we did in the assembly language, to the strings of zeros and ones, we assigned some words. To those words, we actually called mnemonic. So suppose there is an instruction. If I wanted to give an instruction to add two numbers, and for that we have some strings of zeros and ones. So 1100 is the instruction to add two numbers. So instead of giving 1100 as an instruction to my hardware, I will use word add, English word add, and I will ask my compiler to translate it for the machine. So what I will do, I will use add as English word. It is close to me. Then there will be some translator which will be sitting in between, who will take that add and then it will translate that into 1100, and then it will be forwarded to machine to perform the addition. Now this language, assembly language, was really good because it is little bit closer to human being, and also it was little bit away from the machine language. So that's why we called it as a middle level language, assembly language. For a time being, it was okay to work with the assembly level language. But again, as the complexity of the software went on increasing, we needed to find out something smarter to work with. And for that, we then invented procedure-oriented language, to also we sometimes call as a functional language. So that is nothing but the C. So instead of giving an instruction in the form of add and all that, we started using functions. So main is the one function that in that we will write down something. So here we changed the way of looking at the programming. So we divided the entire problem into the small functions or procedures, and then we will write down the procedure. We will combine this procedure and then we will execute it at once so that entire problem will get solved. So that was the approach in the procedure oriented language where C stands. But again, there was a need to change this approach also, because not everything can be divided into the functions. When we talk about the real life problems, we always talk in terms of real world objects. We never talk in terms of functions. We always talk in terms of objects. To that I will give an example. Let's say suppose if I am feeling hot here, I will generally say turn on the fan. Okay, because I know fan is the object which will rotate the air around me and I will feel cool, calm. Isn't it? I will never talk in terms of functions. I will never talk, let's turn on the button, it will pass on the electricity to some motor, that motor will start rotating the blades and the air around it will start circulating so that I will feel cool. I will never talk in terms of functions. I will talk in terms of object. I will simply say turn on the fan. Let's say suppose I am feeling dark around me. I will simply say turn on the tube light. Isn't it? Because tube light is a real life object. I will say turn on the tube light or turn on the bulb. Turn on the light. Isn't it? I will never say turn on something which is illuminating the light around it and which will spread the light around it. I will never talk in terms of functions, but always I will talk in terms of real world life objects. Isn't it? So that's why there was a gap in between real world and the programming. And that gap was bridged using object-oriented programming. So this entire statement, object-oriented programming itself is telling you what is different in it. So it is more oriented towards object than the procedures. In earlier C languages, we were talking in terms of functions. So we'll write down main function, we will write down some other functions for performing certain tasks. But here, we will not think in terms of functions. Instead, we will think in terms of objects. So whenever you will have any problem statement in front of you, instead of thinking in terms of functions, how you will divide it, you will start thinking in terms of objects, that how you can divide that problem into different objects. And that's why it is getting more close to your real world life. And that's why programming has been made easier using object-oriented programming. Hope it is clear to you now. Let's first try to understand how procedure programming works. So let's say you got a problem statement in which you have to design an application for the college. Now in the college you have faculties and you have students. So in the procedure programming language, what you will do, you will first consider as a student what functions you will need to have. So you will have some functions over here, for example, get data for the student, then put data for the students. Then also for the faculties, you will need some functions. So get data for the faculty, then put data for the faculty. So similarly, you will start dividing entire problem statement into the small functions. Okay. And also for that you will have a data. So sometimes you will have a data which is locally available to that function, to which you will call as a local data. And sometimes you will have a global data which will be accessible for all the functions. For example, name of college. Now name of college you will never save in the function 1 or in particular function. Instead of that, you will save that data as a global data because that is common for all, isn't it? For example, college phone number. Again, that you will never store in the form of functions local data, but instead you will save that as a global data, isn't it? So here there is a problem. Once your program starts increasing, once the complexity level gets increased, at that time it becomes difficult to manage with the functions because you don't know which data is connected to which function. So if you modify the global data, to which other functions it will have the impact on, that is very difficult to understand sometimes. So that is the problem with the procedure programming. But the approach is like this only. You will have the problem, you will divide that into small functions. Sometimes you will have a data associated with the functions. Sometimes you have a data which is available on a global level. So that data will be available for all the programs or all the functions which are under that program. Right? So that is the procedure programming. Let's continue with the same problem statement, and now we will see how we can solve the same problem using object-oriented approach. So in the object-oriented approach, you have to first find out number of objects that you have to deal with or that are possibly in your problem. So in the college database management, you have two objects. One is a student and one is a faculty member. So you will create an object student and then you will create an object faculty. Now here you will have a data and a function which is exclusively available for the student, which is different from the faculty's data and faculty's function, because functions are not same. For a student you are different functions. Student's data is different from the faculty's data. So instead of saving that data, instead of having that data on a global level, here we have divided that data in the form of different objects. And every object has got its own data and its own functions. So now the thinking of our attitude will be different. We have to think in terms of objects. Instead of thinking in terms of functions, you have to think in terms of objects. And once you decided the object, then you have to think about what possible data we have to store about that object and what is the function which is associated with that object. So for the student, you have a data like roll number, then phone number, then name, then class, then division, then percentage. All that data will be associated with the student. And what might be the functions of the student object? So for the student object, they have to appear for the classes, they have to appear for the exams, they have to submit their assignments on their time. So these are nothing but some of the functions which are associated with the student, isn't it? Now functions and data is very closely related to each other, isn't it? Similarly, we have another object, that is a faculty. Now for the faculty, we have a different data associated with them, isn't it? So for the faculty, we will have a name, then we will have a designation, then we will have a department, then we will have their expertise. So all this is nothing but a data which is associated with the faculty. And faculties are supposed to function in a different than the student, isn't it? So now faculties will get different functions over here. So faculties are supposed to conduct classes, they are supposed to prepare for the practicals, they are supposed to conduct the exams, they have to assign the assignments, they have to evaluate the assignments, they have to evaluate papers. So faculty is entirely different object. They got their own data and they got their own functions, isn't it? And now there is an interaction between them also, because isolatedly only student or only faculty cannot work. So they have to work collaboratively. So there should be their relation. There should be some communication between the objects. So now object 1 and object 2 has to interact with each other, isn't it? So if we are saying student and faculty, now faculties are supposed to teach to students. Students are supposed to take the lessons from the faculty. So there is certain communication between the objects and we have to establish that relation. So this is how object-oriented programming works. So you have to divide the problem into the objects. You have to identify their individual data and individual functions. That is, you have to implement. And once objects are ready, then you have to make them interact with the other objects in order to complete the entire structure of the programming. So then objects will interact with each other and then they can communicate and they can solve the problem that is assigned to them, isn't it? So this is how object-oriented programming works. There are some other differences in object-oriented programming to the procedure-oriented programming that we will see in some upcoming lectures. Having said that, we'll conclude today's session. Hope all of you have enjoyed it. You learned something new and it sounds exciting to learn object-oriented programming for all, isn't it? So having said that, we will stop over here. If you have any queries, we will have a session immediately after this recorded session. So in that, we will solve them. And we'll meet again in another session. Till then, thank you.